draw the Lewis structure of carbon dioxide. So first step is add all the valence electrons. So valence electron, carbon has 4 valence electron, each oxygen has 6 valence electron. If I add them together, so I will have 16. If I divide that with 2, so we'll have 8 pairs of electron. Then we need to identify the central atom. So less electronegative will be the central atom. So carbon is a central atom, and I will put oxygen around carbon, connect them with a bond, and distribute the remaining electron on the outer atoms until they will have 8. So 2, 4, 6, 8, 2, 4, 6, and 8. We can see there are only 4 electrons around carbon, but carbon follows the octet rule, so we need to shift 1 pair from here and 1 pair from here between carbon and oxygen. So as a result, we will have a double bond, C double bond O, and on the other side we'll have C double bond O, 2 lone pairs on each oxygen. So now both oxygen and carbon, they follow the octet rule. Make sure when you draw the Lewis structure, you must draw or show all the electrons. 2. Annotate the Lewis structure in B1 to show the polarity of the bonds by adding symbol partial positive and partial negative as appropriate. 1 more. Explain the molecular geometry and polarity of the carbon dioxide molecules. So carbon is less electronegative and oxygen is more electronegative, hence carbon will be partial positive and oxygen will be partial negative, and we can show with the help of dipole array and on this side as well. So that will give us 1 mark. Explain the molecular geometry of and polarity of the carbon dioxide molecule. We can see there are 2 electron domains around the central atom. Carbon is a central atom, so we can see there are 2 electron domains, because double bond is considered as a 1 electron domain. So there's no lone pair. We can say the geometry is linear and bond angle will be 180, as we have 2 bonded pairs around the central atom. The individual bonds, they are polar due to electronegativity difference. So individual bonds are polar, but molecule overall is non-polar. So non-polar molecule, symmetrical molecule. So individual dipoles cancels each other. So individual dipoles cancels each other. State the hybridization of the carbon atom in carbon monoxide and in carbon dioxide. We're looking for how many domains, electron domains, will be there around the central atom, and that will help us to decide the state of hybridization. So in carbon monoxide, we have C triple bond O, and there's a lone pair on carbon. So we can see there are 2 domains. Triple bond is considered as a 1 electron domain and lone pair is another electron domain. We are looking for 2 hybrid orbitals. So one S and one P, they will merge together and they will give us 2 new hybrid orbitals. Hence hybridization in carbon monoxide will be sp. Let's draw the Lewis structure of carbon dioxide. So carbon dioxide is C double bond O, and there are 2 lone pairs on this oxygen. Similarly, we have C double bond O, and there are 2 lone pairs. As we can see, around carbon there are 2 electron domains. Hence, we are looking for 2 hybrid orbitals. So S and P, they will merge together and they will give us 2 new hybrid orbitals. Hence, the hybridization will be SU as well. State the number of sigma and pi bonds in carbon monoxide molecule. Sigma bond is formed as a result of head-to-head overlap of atomic orbitals. So we have 1 sigma bond and we have two pi bonds. Pi bond is formed as a result of sidewise overlap of parallel p orbitals. So sigma bond in carbon monoxide is 1, pi bond 2.